Hello, good morning, afternoon. Welcome, lesson 72. We're keeping on going. Tangents and circles. I am going to stop right now real quick and say, hopefully by the time you watch this, I will have your last test graded. Those grading things online really kind of drove me crazy. That's why I did the quiz differently, just to see if that would work. I'm not sure exactly what we're going to do, but I am looking to have a test next Tuesday. It'll be through lesson 70, so we're already caught up through that. We are going to keep doing lessons this week. Maybe Monday I'll do a video like this to review that instead of the Zoom, just maybe so everybody will watch it. I don't know. We'll see. So, again, we're going to keep going. My goal still, through till the 15th, until we're done, we're going to get through 80. So that's not that bad. That's only 8 more lessons. So that's kind of my goal every year, that we're going to get to about the same place, regardless of whether we have a final or not. We will have a last test. So that's pretty much it. So I'll kind of try to keep you guys posted on that. Try to maybe even get an email to your parents. Not real great at that. So here we go, back to lesson 72. This is a part 2. So we need to review a little bit. What is a tangent? Not that we get off on, no. But in geometry, a tangent is a line that intersects a circle. Intersects a circle at exactly 1 point. Do you remember what that point is called? I'm going to put a comma there, which is called the point of tangency. Okay. All right, so today we're going to talk a little bit more about tangents. I'll get rid of that one little dot. It's driving somebody crazy. That are called common tangents. Means we're all off on the same tangent, right? Yeah. Of course. A common tangent is a tangent that's to 2 circles. A tangent line that intersects 2 circles. I guess technically it could connect more if we want to talk about that. And common tangents can be external, meaning on the outside. I don't know how to spell that as I'm talking. I'm adding an extra T. That's what I'm doing. Or they can be internal, on the inside. So what would that look like? Okay, an external tangent, we're going to kind of draw some small circles up here. Maybe they're not that small. Okay, external tangents will be a line that's on the outside of the circles. Okay, I could draw 2. Okay, I'm going to scroll down just a little so we can see this a little better. So here would be, the tangent would be hit this circle at one point and this circle at one point. This could be an also. I knew that one wasn't going to work. Of course. There we go. Make it happen. Draw another tangent, external tangents. Okay? These are my external tangents. I'm having trouble spelling external today. What would an internal tangent look like? It would be one that would go between the circles. Okay, so this is an example of an internal tangent. It would go between them and hit kind of on the inside of each piece of the circle. Okay, so let's recall, Theorem 58-3 with the last time we talked about tangents and circles. If 2 tangent segments are drawn to a circle from the same exterior point, then they, meaning the segments, are congruent. Okay? would that work? My blue lines up here, could they keep going and meet at a common external point? Yes, they could. So if we knew that, then we could say this segment and this segment would be congruent. Correct? Yes. What about, I'm going to change colors again, if I go from this external point all the way to the second circle, and this common point all the way to that external point? What about those green lines? Pretending that this small little circle wasn't there. Okay? Would these green lines be congruent? Yes, they would. Okay? Well, what do you know now? If this green line is congruent to this green line and the pink line is congruent to the pink line, what can you know about the distance from here to here and here to here? Logic should kick in there. Do they have to be congruent? Yes, they do. Somewhere it tells us about that. Yeah. It's going to happen no matter what. I'm going to go to the next page and draw internal and look at the exact same type things. Small circle, bigger circle, and we're going to pretend I can draw. I'm going to move them closer together so I don't have to draw lines that far away. Okay. So here we go. Internal tangent. Okay. And then could I draw another internal tangent? It's always the second one. We're just going to pretend here. Yeah, I know somebody told me that they missed my class because I pretend a lot. We're going to pretend that this is drawn to scale, okay? So, there's something we can know about an external tangent, okay? Could we say that same theorem that said two tangents intersect at an external point? Could we forget about half of this? I know you can't see me marking out the other half, but this be my external point, and it is tangent to this circle from here to here. What do you know about those two segments? They have to be congruent to each other, okay? What about going this way? The same external point meeting to the tangent to the circle. What do you know about these pink sections? They must be congruent. So then they do a problem and they give you 2x minus 10. I'm going to erase just a touch. I didn't mean to draw that pink line so far out there because I knew that I didn't. All right, so this pink line is congruent to that pink line. And now they're going to tell us that this section is x and this section is 2x minus 10. It's probably not going to be drawn to scale. And this is 12, and this is x plus 2. Okay? Can you solve for x and then find the length of every section of the blue sections and the pink section? Really quick, can you solve for x? What do you know x is? Immediately, it's 12. Okay? X has to equal 12 because these two pink sections are congruent. And if you have x is 12, x plus 2 is 14. Sorry. X plus 2 is 14, and 2x minus 10 was 2 times 12 minus 10, 24 minus 10. That has to be 14 also. Did it make sense that these two sections had to be the same also? Of course. Could we have done that differently? Could we have said 2x minus 10 equals x plus 2? Add 10 to both sides. Sorry, making it 12. So here we have x plus 12, 2x, subtract x, x equals 12. we go and plug it in. It works. It has to work. Okay? All right, they have tangent circles. We've talked about tangent lines a lot. What about tangent circles? What does it mean to have a tangent circle? It is two circles that touch at one point. Okay? Tangent circles are coplanar circles that intersect at exactly one point. I'm still on draw. Tangent circles. Okay? Coplanar circles means they have to be on the same plane. Coplanar circles that intersect at exactly one point. Okay? That would be called the point of tangency of circles. Okay? They can connect externally. This is what they've done here. Okay? Meaning they're on the outside of each circle. If we wanted to have an internal, they would simply just be inside of each other. Okay? The point of tangency would be inside each one. Okay? Now, one problem that I have seen over and over again with tangents, okay? With tangent circles more specifically. I'm going to look at the first one that I did. If you know the radius of a circle, and the radius of a circle hits a point of tangency, what do you know happens at that point? That's right. It must intersect at a right angle. Okay, so if I were to draw a line, this would intersect at a right angle, and so would this. Okay? Then they're going to draw a triangle to that. Let me make sure that I have the whole thing drawn out like they would have drawn in the book. So I'm going to grab my book real quick. So they do the straight line across. They put a point down here. And then they put a point that goes to the edge. I know I drew mine upside down. Okay. If you know the radius of circle Q, the radius is 5. And the radius of circle M, which they put here is M, the radius is 2. They do give it units in centimeters. Find the area of this triangle. They name it. This is P and that's N. Can we find the area of this circle? Did we just talk about something? They do say something about N to P is a tangent. So if N to P is a tangent of circle Q, does this also have to be a right angle? Yes, it does. All right, so now let's go look at some things that we know in our triangle. Okay, if we know the radius, do we know this length here is 5? Yes. Okay, really what we're trying to find the area, you need the base and the height. It's what connects that right angle mark, correct? So I need these two lengths. I have one of them. Do we know the distance from P to N? No, we really don't. But could we know the distance from Q to N? This is a radius that's 5. Here's a radius and another radius, which is a diameter, which we need to use for circle M. So from each circle, that's going to be 4. The diameter of circle M would be 4. From Q to where the tangent is 5. So do we know the hypotenuse of Q, which is the length from Q to N? Yes, that's 9. Can we find the length from P to N using the Pythagorean theorem? So we have 5 squared plus x squared equals 9 squared. I'm going to go ahead and go a little quick. X squared equals what's 81 minus 25. I got to actually think about this. It's 56. Correct? So, what's the square root of 56? If we want simplified radical, can you do that? I hope you can. All right, so x, how do we find x? Square root of 56. What goes into 56? Does 4? It does. The square root of 4 times the square root of 14. Okay, I'm just trying it in my calculator. I know you can't see my calculator, but I'm trying numbers. 14, will 4 go into 14? No. Will 9? No. Is that 14? Just going to leave it. So x would equal 2 root 14. Now, ultimately you need to follow directions. If the directions say to the nearest centimeter, then plug it in your calculator. The square root of 56 is 7.4833, etc., etc., etc. Okay? Now, wanting to find the area. Area of a triangle is 1/2 base times height. Okay? 1/2 base times height. I might leave it like this because I like to reduce the 2 and the 2. Okay? So I know the area is 5 root 14. If it asked me to give square roots, 5, I would put in 5 square root of 14, and I would get 18.708. Approximately 18.708. I'm just going to do 18.7. We had units. It was centimeters squared. Okay? That is the area of triangle PQN. So that's somewhere they might ask you. They talk about gears and mechanics. They might talk about the moon and the earth. 2 circles that are not near each other. Okay? But just know that those tangents have to be equal to each other. Okay? We're going to kind of cut this a little short. I'm trying to make my videos a little nicer, which is sometimes correlates to you guys as a little shorter. So, I'm going to assign lesson 72. Practice. And we're just going to kind of do a little bit of a review of 1 through 4. Okay? Not too much. Have a great day. I think it's Wednesday. Talk to you later. Bye.